All right. We are going to get started. If you're here for the workplace noise webinar, you're in the right place. I'm Bill Holliday, and I will get started in a minute. This should take about 20 minutes. If you have any questions as we go, please feel free to use that chat feature on the right. If you're unable to hear me, or if I'm going too fast, you want me to slow down, just write a question in there and I'll do my best to answer those as we go. I guess I'm going to just get going. If other people join, that's great, and they can see the rebroadcast on YouTube later if they need. So we're talking about workplace noise, and the goals are just to understand workplace noise. Why is it important? How do you compute the exposure? How do you convert between dose and 8-hour exposure, and then noise mitigation methods? So why is factory soundproofing such an issue, or why is it important? It's an issue a lot of times because you have these loud pieces of equipment, generally in very large volume, with hard cleanable surfaces, areas, and so you get a lot of reflected noise. The reverberation time, or the time for noise to decay in a lot of these facilities, can be very long. So you're getting direct noise from equipment and then that reflected noise. Issues, if you do have a too loud of an environment, you could have poor communication and could have hearing damage, which could be a cost for the company for sure. So how do you compute noise exposure? I think I have you can calculate it. I mean, there's formula to calculate, but there's easy lookup tables, and this is sort of a general, or your sound level meter will compute it, or dosimeter will compute it automatically. But it's nice to know how much noise exposure you can have for how long. So the permissible noise levels is 90 decibels for an 8-hour day. 12, the lower noise you're exposed to, the lower the levels, the longer you can be exposed to it. Higher the levels, of course, it's going to be less exposure. You can add those together. So if, for example, you're at 90 decibels for 4 hours, that would give you 1/2 of that accumulated dose. That would give you 1/2 of a dose. And so if you're at 90 for 4 hours, and then you're at 92 for 2 hours, what's that, another 0.3, you're up to 0.8. And if you're at 100 for half an hour, and that's another 0.25, and then you're over the 1 dose. That's kind of how this dose works and this formula works. You can hand calculate how much time people spend in different areas and then compute how that exposure compares to the limits. Yeah, I think that's, and then this dose or duration, this will be different, this formula in these tables in different, well, if there's different regulations. So this is for the US, but I know Mexico has slightly different factors here. So you just have to be aware where you're at. And you were doing A-weighted sound levels. So if you have a sound level meter that you're measuring with, you want the weighting on A. Slow response. I think that's it with that. I guess when you're looking at evaluating a situation, this is important. So you can put a dosimeter on a worker, but it's just going to give you the total exposure for that workday till you take it off. So it could be that they're getting a lot of exposure in actually a quieter place, and there could be some very loud places where they're not there much, so they're not getting that much exposure. And so it might be more critical to reduce the noise levels in the lower noise level area because they have more time there. So it's helpful. I mean, a lot of times we'll do a survey and we'll go around the facility where workers are, and then interview them about their workday or follow them a bit just to see what percentage of the day, how many hours, how many minutes in each area. and get the levels. And so then we can calculate, oh, they're getting a half a dose here, a quarter dose here, a third of a dose here, and figure out what's most cost effective, what's the best way, make the most impact to get the levels down or that noise exposure down. Okay. So when you have a problem, you know which area you want to treat. You really just have 4 options. You treat that source, you treat the noise path, you treat the receiver, or this is kind of treat the receiver. You limit the time in certain areas. So I just stepped through these. Treating the noise source, we're looking at treating that equipment, and that could mean replacing it. It could mean maintenance. We've seen that. It could mean boxing it or partial enclosing it. You could wrap it in some kind of heavy damped material with some kind of decoupling material. Like a lot of times we use fiberglass and then loaded vinyl over it. You can enclose it. Just make sure that you have, things don't overheat. You have ventilation. You have, give it enough space to operate. A lot of times you want to do a hard surface or a surface where noise isn't going to easily pass through, a lot of mass, but then put absorption inside so noise levels aren't building up inside. You can change location of equipment. We've seen that happen even where you buy 2 smaller units and just spread them out so you're not getting as much concentrated noise in one area. So treating the source, treating the path. So as I said before, there's 2 noise paths, or 2 ways noise travels, but there's 2 paths for noise. One's going to be that direct path. And so if you were to just remove all the walls in the building, take away the ceiling, you're out in a field with that equipment, every time you double the distance from that equipment, you should be getting about a 6 dB noise reduction, depending on how far away you are. Once you get further away, it's really a point source. And so doubling of distance will give about 6 dB noise reduction. There's air. I mean, when you get into large distances, you get more atmospheric conditions, but within a factory, generally, that's not an issue. That's direct noise. And the only way to block that, or the only way to attenuate that, is blocking that path. So putting up some kind of barrier, some kind of treatment. The other path you'll see is reverberant. And so you take away that initial noise, and we're counting all the reflections from the back wall, side wall, wall in front of the equipment, ceiling, of course, floor. All those reflected paths will add up. And that gives you the reverberant path. And how you treat a reverberant path, that's going to be more absorption. You're trying to treat the walls, ceiling with some kind of absorption. Anywhere on the wall above head height or above noise source height, I guess that's above noise source height, it's going to hit the ceiling eventually. So a lot of times, if you treat the entire ceiling, you don't have to worry about higher up on the walls. One of the more ideal areas to treat are going to be ceiling and walls near ear height. So generally 4 to 8 feet high, or 3 to 7, somewhere in that range, ear height. And so that'll get rid of the wall treatments, can get rid of some flutter echoes and some of the reflections, the first reflections that are hitting people. I guess the ear height, but it's really, if you draw the path from the noise source off the wall to the person, it could even be higher, depending on how high the noise source is. So it's good. I think, I have a formula here. You look at the sound power, you can calculate this reverberant noise and this direct noise. So you can just hand calculate it. You can also use an acoustic camera to block out the direct noise and see how much is coming from reflected, actually aiming at ceilings, walls, and looking at what the levels are. but you can also calculate it. And also, if you're stepping away from equipment, how fast it decays the noise will give you an idea what the influence is of the direct and reverberant. So if you step back, double your distance back, and the noise level isn't going down much, you're getting a lot of reverberant reflected noise, most likely. That's assuming if you have just this one source operating. If you have other sources, it gets more complicated. But this is looking at, and it's in our little guidebook, but the room constant, the distance, and the Q is a little reflected factor, if it's in a corner, if it's on a hard floor, if it's, excuse me, against a single wall. There'll be some immediate amplification depending on where it's located. I think that's it. The third option is to treat the worker, and that's hearing protection, some kind of booth or local shielding. If I have pictures here. And then something right on the person. I mean, that's your last resort. It would be nice if you could treat the source first. I mean, that would treat it for everyone, no matter what's happening in the facility. Barriers and absorption are a nice second option. And closing equipment, that's kind of treating path, but we kind of is treating the source. You know, closing equipment, keeping as minimize your openings. That would just reduce the overall noise level in the whole facility. The other option is reducing the time people are in each area. You could split shifts. You can just work less in one area, and that will, you know, can limit exposure. That's usually not ideal. I'm really putting these in order of preference. If you could treat that source, replace maintenance, and close, that's a pretty global solution. The path with absorption or barriers is a second option. And then a third is directly treating the receiver and then limiting time. Usually that's not desired because you have people with specialized skills, and then based on noise, you're having to change their work plans. So let me, what did I want to say? Yeah, okay. Let me just go to, we're acoustical consultants. We're independent, don't sell any products. We can do installations and get materials if needed, but we do anything with acoustics, environmental, sound impact, room acoustics, anything with noise. And I think that's it. I don't kind of went fast through that, but we're also DB if that helps on anyone's projects. Feel free to contact us. We're in the Southwest mostly, and we've expanded into dealing with projects throughout Mexico, which has been a lot of traveling, but it's good. All right, I'm actually gonna end that right here, and I will take any questions you have. I'll send you to our, this is your little thank you gift. Forgot how I'm supposed to transfer. That might have opened up a new window. I'm not sure. Redirect. Maybe it didn't. Okay, I don't know if that worked. But on chat, there's a link. You can get your updated ebook. And then any questions? I guess there are tables as well between dose, or that percentage exposure, and the time weighted average that can be useful. So if you come up with a dose of 0.5, then you can relate that to 85 decibels. And so the regulations here, actually, that's probably not bad. OSHA in the US says that you need a hearing conservation program whenever employees' noise exposure is equal to or exceeds an 8-hour time-weighted level of 85. and then you need, and then without any special protections. And if you have, yeah, and an 8-hour 85 is a 12-hour 82, if there are a lot of shifts. And then if you do go above that, or if you're in the 90 or above, you do need to do engineering steps to reduce the noise or make steps. But there are tables and calculations just to move from dose, that percentage, to the 8-hour time weighted level. So a dose of 10 or 10